అందరికీ నమస్కారములు. సర్వేభ్యో నమో నమః. గురుభ్యో నమః. Today is the third day of our series of classes on Vedic mathematics by Dr. Goutham Mukherjee ji. This is part of our certificate course on SD. Started on 21st of August and we have completed 6 weeks. So far we have learned all major topics. Starting from Sanatana Dharma, Vedangas, Dharmashastras, Upanishads, Darshanas. And now we are on Vedic mathematics. We also will see Veda Samskriti Ramayanam, Mahabharatam, and some research topics going forward. Simultaneously, we also are learning Sanskritam language. 5 weeks are already over in that. And every Friday we are having some classes. And you can appear for the test conducted by Samskrita Bharati Pravesha exam. And please join the evening classes also of the Guruji. And also we started with yoga classes. So request all of you to do yoga before coming to this class. When the class of Guruji CSI Prabhu Garu is not there, so that you keep the continuity of your exercises. Thank you. Now let us start the session by paying our respects to our country by reciting Vande Mataram and also Prarthana. Let us request Challa Chittibabu Garu to recite Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayaj Sitalam, Sasya Syamalam Mataram, Vande Mataram. Subrajosna pulakitayamini pullakusumita drumadala shobhini suhasini sumadhura bhashini sukhadam varadam mataram Vande Mataram Vande Mataram. Namaskar.
Vande Mataram. ధన్యవాదములండి చల్లా చిట్టిబాబు గారు. Thank you so much. Now let us request Bhaskar Rao Garu to chant Prarthana, please.
No, sir. A 1-minute meditation followed by 3 times Om. नत्वा गणपतिगं हवामहे कविं कवीनामुपमस्रवस्तमं ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पत आनः शृण्वन्नोतिभिः सेदसादनम् ॐ श्री महागणाधिपतये नमः। ॐ प्रणो देवी सरस्वती वाजेभिर्वाजिनीवति धीनामवित्र्यवतु। ॐ श्री महासरस्वत्यै नमः। गुरुरेव गतिः गुरुमेव भजे गुरुणैव सहास्मि नमो गुरवे न गुरोः परमं शिशुरस्मि गुरोः मतिरस्ति गुरो मां पाहि गुरो। ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे। श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पादशङ्करं लोकशङ्करं शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः। ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः। असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय। ॐ शान्ति शान्ति शान्तिः। मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव। ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
గురుభ్యో నమః. హరి ఓం. ధన్యవాదములండి భాస్కర్ రావు గారు. థ్యాంక్ యూ సో మచ్. అండ్ నౌ let us request our Guruji, Dr. Goutham Mukherjee ji, to start the webinar, please.
सभी को नमस्कार, सर्वभूम नमो नमः। This is the book that referred into that one, this slide, one of the slides. It has something like 350 pages or so, all chapter wise, different whatever being taught, most of them are here in this book. You can purchase it in through Amazon. Now we start the session. Yesterday we did division by Nichilam method. So it was seen that by drawing a line like this, the division part is complete in terms of division by the nearest power of 10, and the dividing line is actually quotient left side and remainder right side. But where the divisor may be less here, less than the 10th power. So in each of the blocks, in each of the powers of 10, there will be some contribution both at the quotient side and on the remainder side. So finally we add up all this. So here the after division, after you can see that slightly more amount of division, we are adding certain things to come out to that. It is in contrast with the which is division is taken as a repeated subtraction, and therefore you have to do a lot of tables of 9, 8 and so on. So we did example of various division by one digit, then multiple digit with single processing requirement, then with multiple processing where in one go, if the remainder doesn't come properly, remainder becomes more than the divisor. So therefore, again, you have to do another processing. This should be more and more when the divisor becomes away from the power of 10. So I told that the proper Vedic method is state division, or the non-conventional division is also very good. Actually, it is as good as nothing special about Vedic mathematics of state division, but conventional mathematics, the conventional division is also good for in case of general, you can say general. But when this is close to a power of 10, there is no need of any instead of conventional division. This kind of division, if you are expertise on that, it will be, you will find that it's much easier. So students should learn both of these. This method, anyway, the conventional is being taught in school, so the other one also is taught. Now here actually, this another sub-base technique is given here, where suppose I want to divide by 23, we find that 23 when multiplied by 4 is 92, which is near to power of 10. So all the techniques of power of 10 applies here, and we divide by 92 to get 10 as remainder, and 10 as quotient and 91 as remainder. Now this remainder 91 is good for 92. Suppose I would divide by 92, this result would have been final. But since I am not dividing by 92, rather I wanted to divide by 23, so I find that instead of inside this remainder, there are 3 more 23 pits. And finally, one remainder remains is this 22. And also the quotient actually should be multiplied by 4 times, because it is the it was actually 1/4 times because of it is being divided by 92. So we get back that 4 times, and actually 40 becomes my quotient, and 91 initially got remainder as I told, and then finally this 3 gets contributed. So this 43 becomes my final quotient, and 22 becomes my remainder. So this is the special technique, actually sub-base technique. Now today, my focus will be where it is the divisor is near about a power of 10, but it is above a power of 10. So what to do? I do exactly opposite. It is already name is Paravarta Jojet, means transpose and apply. So I find that it is almost same as the Nikilam method, except this sign change. Here, we could have written vinculum also, but okay, in any case, this notation is also okay, -1 and -2. So it is like this. Earlier, we used to do like this, that suppose something we do Nikilam Navatascha, it is how much it is deficient from the nearest 10 the power. Here, I am doing how much it is, here also I am doing how much it is deficient from the power of 10. Since it is more than power of 10, obviously deficiency is in negative. So that is the idea. -12 is my deficiency. Actually, it is 12 more than the power of 10. So that is the idea. So therefore, I apply the similar technique as Nikilam, but where a sign change. So it is like this. 1 into this -1, -2 becomes -1, -2. 2 minus 1 becomes 1, and as a result, 1 into -1, -2 again is -1, -2. Finally, we add 4 minus 2 is 2, 3 minus 2 minus 1 is 0, and 12 minus 1 is 11. So therefore, 11 becomes my quotient, and 2 becomes my remainder. Here also 1, 1, 2, 3. Here actually it is 3. It is actually 1000. So there are 3 digits here: -1, -2, -3. So it is more than this 1000, 1, 2, 3. So it is -1 to 3 is the deficiency. We write it -1, -2, -3. So 1 into -1, -2, -3 becomes -1, -2, -3, and 3 minus 1 is 2, and this 1, 2, 3 becomes -2, -4, -6. So 6 minus 6 is 0, 5 minus 3 is -4, and 4 minus 2 -2 is 0. Now we get 12 as quotient and -20 as remainder. So this can be, whenever we get negative in remainder, we subtract from the divisor and add 1 to the quotient. It is like this. It is like this. 12 quotient into the divisor plus the remainder. So it is actually negative. So I, instead of writing plus and this minus, that instead I write like this. So since the negative remainder is negative, we write like this. It is same as 11 into 1, 1, 2, 3 plus 1, 1, 0. Because this negative remainder actually basically comes negative with the divisor, and we add up one, I mean, subtract one. I'm sorry, not add. Subtract one. Subtract one from the, because it was excess. Because we took excess, we got a negative remainder. So we subtract that one from the quotient, and the quotient becomes 11, and it becomes, remainder becomes this minus this becomes remainder. I hope it is clear. Divide 2, 3, 4, 5, 6 by 1, 2, 3. So 1, 2, 3 again, minus 2, minus 3. So 2 minus 2 minus 3 becomes minus 4, minus 6. And 3 minus 4 is minus 1. So that becomes minus 2 minus become 2, 3, plus 2 plus 3. And again, 4 minus 6 plus 2 is 0. So we got 2 zeros. And 6 and this 5 plus 3 is 8. 2 minus 1, 0. You know that 2 minus 1, like this, 2 and Coulomb 1 becomes 190. So 190. So 190 and remainder is 86. 86 is less than 123, so no problem. Again, divide 4009 by 882. It is actually case of the earlier one Nicola method, but we do it in a slightly different format. So it is deficiency was 118. It is positive, but here we write in a different thing. Actually, we are doing Nicola, but we take Coulomb. It actually, instead of 18, we write 2 minus 2. Actually, we wrote like this: 2 and Coulomb 2. So instead of Coulomb, as I told that we can sometimes put in the left also. So it is like this. So we exactly did earlier. We did like that. So 4 into 1 to minus 2 is 4 plus 8 minus 8. So 9 minus 8 is 1. This is 8. This is 4 and 4. We could have done with this one, 188 becomes 472. It could have been 72 plus 90 is 480. We could have gotten directly. Here also we are getting the same thing using Coulomb. It is all the same. So quotient becomes 4 and remainder 481. Divide 2699 by 224. So 224, here actually it is 224. It is not near about a tens power, but when you divide it this one by 2, it becomes 112, which is near to a power 10 of power, 10 power. So as if we are now we will divide by 112 first, with minus 1 minus 2 as the excess. So 2 into minus 1 minus 2 becomes minus 2 minus 4. 6 minus 2 is minus is 4. 4 into minus 1 minus 2 becomes minus 4 minus 8. When we add up 9 minus 8 is 1. 9 minus 4 minus 4 is 1. 6 minus 2 is 4. 2 comes 2 here. And now we divided, instead of dividing by 224, we divided by 112. Okay. So as a result, we got an excess of the quotient, double the quotient we got. So therefore, you have to divide by 2. So we are dividing by 2 to get 12, but remainder remains as it is. Remainder will not be affected because here the quotient is earlier, the remainder would have been, say, we divided by 92. So the remainder could have been less than 92, but it is more than the original divisor required, that is 23, it was like that. So we had to again manipulate something with the remainder. But here, that chance will not come because we are dividing by a less already. So in any case, that will be less than the second, I mean, modified divisor. So 11 is already less than 112, so therefore it automatically less than 224. So the remainder remains unchanged. Now, there's some challenging situation may come where here we divided by 2, it becomes similarly this, we are dividing by initially we divided by 2, again we divided by 2, here also we divided by 2, here also we divided by 2. Here everything we got as it was even number, so we got integer. The case may come when it becomes it is odd number, so we may get something like this. 5 is also odd, 2, 3 is also odd, so we get half. Now, what to do with half? How to handle with half? I'll come to that. So we are dividing 1699 by 223. So we half of that is which is near to a power of 10, means 100, is 111 and with a half. So we forget about this half, we keep the half as it is. So it is -1 and -1.5. We join that half with nearest digits, nearest place value. So -1 and so it is 1 into -1, -1.5, -1, -1.5. So 6 minus 1 is 5, and when you multiply 5 with this, becomes -5, -7.5. 5 into -1.5 is -7.5. So 9 and -7.5 it becomes 1.5. 9 minus 1.5 minus 5 becomes 2.5. Okay, and 16 minus 1 is 15. So when again we divide by 2, like we did earlier, it becomes 7.5. And with so 7.5 becomes my quotient, and remainder is 2.5, 1.5, because remainder doesn't change. So it is a result of division by 223. 223 was my divisor original. So after dividing by 2, this 15 and this part was the result of dividing by 111.5. But when we divide it again by 2, it becomes 7.5, and 2.5, 1.5 becomes my quotient and remainder for division by 223. Now, how to handle these halves? So quotient we will denote as 7. So there is no half in the quotient. But this half will come in remainder. How? It is actually the quotient side half means it is the half of the divisor, basically. So it becomes 111.5. Half of, like what you did earlier also, this 111.5 it becomes. The result of this half is this one. Now, this is 2.5, actually in tens digit. So had it been 2, we know that it becomes 20 is the actual value, place value into face value. And if had it been 3, it would have been 30. So 20, 30, it is in between, 2.5. So it must be 25. So basically 2.5 into 10 is 25. So this denotes to this 25. And again with this half is there, or 1.5 is there. So when you add up, it becomes 138. So you can please match that whether the division by 223 of 1698, it becomes quotient as 7 and 138 as 8. So if you
No, it
need
does
some
not actually. There's a
elaboration,
mistake there.
huh?
It does not add up. So 7 times 233 plus 138 is not 1699.
It is not, there is a mistake.
Yeah, 7 times 233 is 163.
223.
223. Oh, my mistake then. I 233. My mistake.
So 7 into 223 plus 138, isn't it?
It's correct. It's correct.
1698. So that is the idea. So if you want to revise, want to tell me to revise, then I can do it.
Clarification, please. The first column, 112 you have taken, and then first 2 into minus 1, 2 into, then you should take the second level, second line minus 4 into minus 1, huh? First column here.
This one, this one.
No, third,
Oh,
how it is getting. Third step. The same one, third step.
oh, 111 and a half. So as I told that, what is the excess? We just remove the one.
Gautamji, it's not the second question, it's the first 2699 by 224.
Okay.
In that third step, she is asking.
Oh, third step. Yeah. So I'll tell you how it is done. So first of all, it is this 2 into 2 is multiplied by 2 is multiplied by minus 1 minus 2. So it becomes minus 2 minus 4. 6 minus 2 is 4.
Okay.
6 minus 2 is 4. So 4 into minus 1 minus 2 becomes minus 4 minus 8.
Okay.
Then we add up, and finally this quotient is again divided because it was came from division. So this also is divided.
Okay.
And it come from multiplication like earlier we did 92. So it would have been multiplication, but here it is division. Again divide.
How did that minus 7.5 come then? In the second question,
This
the
one,
minus
this one.
Yeah.
Oh, this is actually 6 minus 1 is 5. So 5 into minus 1 is minus 5, and 5 into minus 1.5 is minus 7.5.
No, that should be minus 5.5, right?
5 into minus 1.5
Oh, I see. Okay, got it. Thank you.
is minus 7.5. Okay. So this is the thing that we can how to handle the half. So this is also this a presence of half. I wrote it in presence of half in quotient will contribute half of divisor in remainder. That is the main thing to be learned here. This 7, this half contributed to 111 and a half out of that. Finally, everything will be coming to integer because we are dividing one integer by another integer. And wanted to find out quotient and remainder, nothing like fraction. So everything will be in finally quotient and remainder will be in integer only. So that all the halves will be all nullified and each other and so on. So is it okay? We understood? We just practice it and they will find it. You can ask me to do any of your own problem. You please devise one problem. Let me see how it can be done from previous ones and so on. This one or Nikilam. You tell me. Let us see any new problem.
Gautam ji, 1 minute.
This one. Any problem?
Is anyone trying to answer or raise a question? Otherwise, we'll go forward. We can't waste.
1 minute.
So, tell me, any new problem you do? Some new problem? Say 2718. Okay, take the number. I should divide by what? Let us try with simpler ones. Say 113. Shall I do? Now tell me what to do. Suppose I am dividing 2718 by 113. Just would have quotient and remainder. We should find out, no? So you tell me what to do first.
Here minus 1, minus 3.
What I do first.
One 1, 3.
-1, -3. -1 and -3, right? Now, what would be my next step? Now, the first step is what? Where should I put the line? Quotient and remainder division?
Here, 1, 8.
1, 8.
After 27, you put line.
Yeah. Acha. Now, -1, -3. What should I do here?
-1 you have to put here, -1.
-2.
-2. -2 below 7, isn't it? -2
-6.
and -6. Yes. Good. Now,
This is 5.
5, then
5 into 1.
-4, minus.
no.
Minus
It's 5, no? 5, then minus.
5 into -1. -5.
-4.
-5.
Here, this becomes -15.
-15.
-5.
Now, these are very challenging terms sometimes. The challenging problems come.
-5.
Okay. So basically, it is actually we are separately we are doing. Basically, it is actually -6, 5. Actually, it was actually -13. So -13 when we multiplied by 5, it becomes -65. So basically, this one will add up with this one. So instead of that, we could have written -6 and 5 only. So when we add up, so actually instead of that, we have to consider, I put in bracket. So it is -6 and 5. Okay. So 8
into 5.
minus 65 to -6 -5. -5 8 minus 5 is 3. Here it is 1 minus 6 is how much? -12, and this becomes 11, -11. So like this. And it becomes 25. Now this becomes a challenging actually. So this means how much?
-11, 3.
9, 3.
-7.
Okay, now how much becomes with this one? So how much is the value of this one?
10. 107.
107, 107 isn't it?
107.
So value of this is actually it is
Ah,
-107. I can write.
Yeah.
So this is opposite sign. So it is actually -107. So basically it is taken 25 into 113 -107. First, let us first check whether my everything evaluation was correct or not, isn't it? It just need practice will come because this always new problems come like this. So we'll do 25 into 113 minus 107.
It's okay.
2718. Yes. So this is correct. This procedure is correct, isn't it? My procedure is correct.
Yeah.
Now, how to handle this? Basically, it is negative quotient. So basically, it will be. It means 20. It will please tell me. It means what?
26. And then we can make it positive.
No, negative. Actually,
24,
it is
24,
24.
and then 113 minus 107, which is
113 Now I will subtract this 113 minus 107.
Yeah.
Basically it is, so therefore it is 24 into
6, 24 and 6.
24 into 113 plus 6. Please check whether it is correct.
Correct, sir.
Yes. So this is the procedure. So here actually, although I am doing it separately, you have to mind it here. Actually, could have written like this: 13 vinculum. Basically, it is 13 vinculum. So, but still actually write 26 vinculum. It will be writing is very inconvenient. So therefore, this kind of things is being done. The notation. But when this comes in one place, that means in both comes in remainder side, we can very well combine them to write -6 -5. Okay, so therefore we operate accordingly. This becomes positive, this becomes negative. How to handle that? It is the opposite of vinculum. Here it is. This is the vinculum side, and this is the. I mean, no, it is actually. Either you write this or this. You write this. Writing this, it is -107.
Okay, can you please refresh my memory? How do you put that line for quotient and remainder?
Oh, it is actually it is near about that power of 10 where there are 2 zeros.
Okay.
So it is 100. So dividing. So it is like this that as if I am dividing by 100 first. So if 2718 is divided by 100, then there will be 27 will be my quotient and 18 will be my remainder. But it is not. It is not 100 we are dividing by. We are dividing by 113. So in each of the blocks there will be negative contribution.
Yeah.
Negative contributions. So we are adding up all the negative contributions. Finally, add up with a. Instead of 27, you are getting 24 finally. Okay.
Okay, got it. Thank you.
Okay. Any problem you can think of for that? Then we can go to. You can see like, if any problem comes, we can get back later with any of the chapters anywhere, multiplication, division, etc. So therefore today, let me start with another one. Is it? Should I do it?
I think you can go forward.
Then any problem because
We'll
let's
revert
see
back.
how to manage time and so on. But
Right.
you always remember, you always note down wherever you have questions or anything, you try yourself multiplication, division, whatever you learn, you learn these things. You can also privately on my WhatsApp also you can answer. Ask for the answer. Is this something screen is coming like this? In my screen.
Yeah, we can see the screen.
Yeah,
Yeah.
divisional, rational fraction and decimal form.
Something is coming on my screen and it is blocking. Okay, so division, rational fraction, and this thing, and decimal form. Okay, so thing is happening on my screen. So far, we have seen division of a dividend by a divisor to yield quotient and remainder. We ended up there. Relation between these are if E is the dividend and divisor is D, then E is equal to D into Q plus R, as you know. So when you divide by D both the sides, we get E by D is equal to Q plus R by D, where R is less than D. That is the condition of a remainder. If remainder becomes more than the divisor, obviously one more will fit there. So that is not the, we have since childhood we have seen that whenever we do some mistake, our teacher tells that no, you committed a mistake. There would have been one more quotient. So it actually happened. This one more is contributed to our quotient, and remainder finally becomes less than the divisor. Now, depending upon the requirement, division may be left out. Division may be left out at finding only Q and R. Or result may be expressed in whole Q and fraction R by D. Like this, in this form also we write. Like this 15 divided by 4 we write Q is equal to 3 or R is equal to 3, or we write 15 by 4 is equal to 3 whole 3 by 4. or you can say that 15 by 4 is another notation we can do. You write in 3.75. This notation is called decimal notation, and there is a lot of property of the decimal notation. Sometimes it may be terminating, it may be non-terminating, or depending upon the decimal notation, lot many things actually, the whole lot of things actually, concepts emerge out of this. What will be the decimal notation? For an expression, any problem? For an expression E by D, where E is greater than D, it can always be expressed as a whole part plus a fraction of the form n by d, where n is called now numerator and a denominator. So we are, instead of r, we are not in normal fraction. We, instead of remainder, we are using now the word denominator, and instead of divisor, we are writing the instead of n remainder, we are using the numerator, and the divisor we are using denominator when a fraction in form of the form n by d. So for an expression E by D, where E is greater than D, it can always be expressed as a whole part plus a fraction of the form N by D, where this example is given. There is the fraction 15 divided by 4. So 3 was my whole, and 3 by 4 of the form of N by D, where N is, numerator is 3 here and denominator is 4. We write in this form. Now, I come to this one. That fraction where n by d, n less than d. So n less than d, obviously there will be no whole part, and two decimal form. What are the different situation may arise? Any rational fraction of the form n by d becomes a terminating decimal when the denominator d is purely comprising of powers of 2 and 5. This is very important because we are using a decimal number system where decimal is 10, it has two factors, 2 and 5. So therefore it is happening. Had we use a hexadecimal number system, this only one factor is there, is 2, power of 2 only. So therefore only in case of 2 this would have been true. But here in case of power of 2 and 5, this will be a terminating decimal. So like half is 0.05, 1/4 is 0.25. So we are converting basically a fraction of the form n by d, n less than d, to a decimal notation. So 0.5, 0.25, 3 by 4 is 0.75. We all know that 1 by 8 is 0.125, 3 by 8 is 5 is 1 by 5 is 0.02, 3 by 5 is this one, and 1 by 25 is like this. A rational fraction whose denominator d ends in 1, 3, 7, and 9 becomes purely a recurring decimal. This is very important. Purely recurring decimal.
That's because 2 and 5 are factors of 10, whereas 1, 3, 7, 9 are not factors of 10, right?
Exactly. Not only that, 1, 3, 7, 9, not only that factor of 10, they do not contain also a factor of 10. They do not contain. In the 1, 3, 7, 9, these are not cannot be factorized in terms of factor of 10. So that is.
Sir, how about 1 by 32?
I'm coming to that. It's the next slide. So now it becomes purely a recurring decimal. So 1 by 32 comes under this one. 1 by 32 comes under pure power of 2 here. 1 by 32, it is 0.0 0.00 will come, something like that. Let's see. 1 by 3 is 0.333, okay? 1 by 7 is 142857. Again 142857 and so on. This becomes 3 and all 3, 3, 3. And 1 by 11 is 0.0909 and 09. So what we do? Sometimes we do like this. we put a dot here. This means we need not have to write other this one. Here also, we need not have to write the smaller ones. Smaller notes. Do what you do? We put a dot here and dot here, beginning and end of the recurring sequence. Here also, it is 2 digits only. This one and this one. This we do not write. We do not write these ones. These are extra, like 8 by 13, like this. Here, we put a dot here, and this just to show that it is repeats actually. I want to show that way.
Sir, but 1 by 2 power 4 will become 16 and 1 by 2 power 5 will become 1 by 32. So for that cases,
1 by 32 is purely power of 2, no?
yeah, 1 by 2 power 4. Like 2 power 4 become 2, 2, 2, 4, 4, like 16. And I'm talking about 1 by 2 power 5, 32. So it will be also same, like it will be terminating or not terminating.
It will be purely terminating. Okay. So 0.0625 was 0.625. No, this was 116, and this will be point how much? It will be 0.313125, isn't it? 1 by 32.
0.03125, like one more zero need to become. 1 by 32 will be 0.03125. You are
Sorry,
correct.
zero,
But
yes,
after
yes,
point
zero,
you need to have one more
zero,
zero. Yeah.
yes, actually. 0 is there. This 0 is here only, because this 124, this one, after that coming below will be 0, and 0.6, and it will be 0.3. Again, always doing half of that. No, 1 by 8, 1 by 16, 1 by 32, all will be half. So there is a formula why this should be coming. There are 1 by 32, 2 to the power 5. So there will be 5 places of decimal. 16 to the 4, so there will be 4 places of decimal. These all coming to that. Now, there is third category. So, so far we have done 2 categories. One is purely, the denominator is important. Purely comprising of powers of 2 and 5 becomes a terminating decimal. And a rational fraction whose denominator ends in 1, 3, 7, and 9. These 4 numbers you remember. So this will be purely a recurring decimal. Anything other than that, a rational fraction other than the above 2 categories will have a non-recurring part followed by a recurring part. This is important. Here, 1 by 6 is, there will be a non-recurring part I put in red, and then there will be a recurring part. Let me put a dot so that we don't have to. This is dot is there. Don't have to write this one 666. I can cut it. So here also 0.5 and then 3 like this. And like this, so 14. So 6 and then 4, 8, 2, 5, 7, 1. Just to show that it is. So it is like this. Length of the non-recurring part in this case, or length of the terminating decimal discussed earlier, will be greater one between the maximum power of 5 and maximum power of 2 and maximum power of 5. Is it clear?
Sir, how about 4, sir? Like we haven't seen a 4. We have seen 2, 5, 1, 3, 7, and maybe here we are seeing 8, 9, 6, 8, 9. How about 4, sir? 1 by 4 is 0.25.
Yeah.
So for that kind of cases, you got it, right? I mean to say we miss 4.
1 by 4 is 0.25. Yes, I've written here.
Okay, sir. No, then in that case we need to say that in the previous slide that there will be a non-terminating occurrence will happen for the 4 also. Like we have missed 4, sir. Here we said 2, 5, and 1, 3 and 5, and again we got here 6, 8. So we missed 4 again. So you can write 4. You can mention 4 also in the previous slide. Yeah, previous slide to this. Yeah. Here we can say that you said that a rational number of the form n by d becomes a terminating ratio when the denominator is purely complementary to power 2 and 5. And again you said that the ends in 1, 3, 7, 9. So here we miss 4. That I want to mention.
4 is a power of 2. 2 square is 4.
Yeah. No, we can mention it because it will be easy to remember. Yeah. Not an issue. Thank you.
Comprising powers of 2 and 5. Why 4 should be considered separately? Because 4 is the power of 2, no?
Yeah, sir, but here we said that n by d becomes a terminating decimal when you have powers of 2 and 5. Again, in this next statement, we said that it ends in 1, 3, 7, 9. We haven't said end with 1, 2, 4, 6, and 8. I
No,
want
no.
to know that. Like the
No,
fraction which is, which is
that cannot happen. That
okay.
end in 2, nothing like that. Ends in 2, 4, 8 doesn't matter. It will not be always pure terminating decimal. That's what.
Okay, I'll try, sir. I'll try and come back to you. Not an issue. Yeah, thanks.
Actually, say 1 by 12. How much is 1 by 12? You try. So it's, oh, sorry. Also 1 by say 9 by 14. Say 4 is coming here. So, but it is a combination of non-terminating and fixed part and a recurring part. Okay.
So 1 by 12 will be 0.0, like it will be 8, and 3 will be repeating, like it will be occurring again.
0.08.
8, 3, 3, 3, 3. So 3 bar we can write, right?
So end in here, end in how much is not important. Here it is.
Okay.
There are two cases are there. Power of purely power of 2 and 5. It can be 32. 32 end in 2 is okay, but it's because it is power of 2. And here end in 1379. That is important. But here others are end in nothing like end in 2, 4, 8, 2, 4, 6, 8 or 5, something like that. No, it is not that. This will be anything other than the above two categories. We will have a non-recurring part followed by a recurring part. Okay.
Recurring part. Yeah.
So because I'll tell you, this is there is a reason behind this. Length of the non-recurring part in this case of or the length of terminating decimal discussed earlier will be a greater one between maximum power of 2 and maximum power of 5. I'll tell you the reason why it is happening. It is coming here. Because a fraction of the third type can easily be transformed. This is important. So if the transformation you understand, then you'll get the answer. Transformed by multiplying both numerator and denominator by either a power of 2 or a power of 5 in order to neutralize the d. Neutralize the d where, neutralize in the sense, anything other. Neutralize means, here I'm meaning anything other than the two categories of either power of 2 and 5 or 1379. Like for the 1 by 6. See, it was 6. So it becomes 5 by 30. So 1 by 10 of 5 by 3. So 5 by 3 is a this one numerator by denominator. You can divide into 1 plus 2 by 3 and by 10. So 1.6666 is actually 1 and this one. This 1 is 1. 2 by 3 is 6.666. And whole thing divided by 10 is because that is the origin of the fixed part, where it is becoming like this. This because it is the full part here. This is the origin of the fixed part, and there will be origin again. There will be ending in 1379 only. Therefore, this 1379 will be yielding this. So these will be two parts. One is fixed part, and another is 1379 type. So anything other than those things can be converted into this. Thus, basically, the third type fraction results from a whole number added to a recurring fraction of second type, that is ending in 1379, and then the whole expression divided by a power of 10. So it would be like this. So therefore, that is the idea where you get a fixed part and a recurring part.
So, sir, you mean to say you are breaking the whole expression into small, and we are trying to find it. Like 1 by 10 is 0.1, we know it. 1 by 2 is 0.5, so you're making easy. Okay, fine. Yeah.
More example, 29 by 74 is basically 140. We multiply, as I told, in order to neutralize this. There is a
Divide by 5 and multiply by
there
5
actually
in
no.
order
I
to
tell
get
you
100.
what do you mean by neutralize? Here, this 6 actually contains 2 into 3. In the denominator, there is a 2 here. There is a 1379 category, but there is also a 2. So we have to neutralize these 2 by multiplying both N and D, numerator, denominator, by 5. When you multiply this 2 by 5, so this becomes 10. And accordingly, this becomes also increase. So that is the idea. Neutralize means that word, the word neutralize means. So 29 divided by 74. Again, this contains only one number of 2 here. Basically, this is 2 into 37. Again, 7 ending in 1379, of course. So 145 divided by 370, 1/10 of this one. So this actually is 3 plus 34 by 37 by 10. So 0.3 and 34 by 37. So this 34 by 37 becomes 0.918, 918, 918, etc. So this and this. So it is basically 3 and 918. Okay.
So it is applicable for all the expression. Like if I have 36 by 89 or kind of other kind of tough numbers.
All these things, yes. 89, of course, 89 is ending in 9, so it will have a purely recurring. Now 29 by 75. See here also, there are 2 numbers of 5. 3 into 25. So this 3 is there, which is category is 1379, multiplied by 25. So I have to multiply both the sides with 4 to neutralize this 25. When 4 inverse to it, it is 5 square, so you have to multiply by 2 square. So 75 into 4 becomes 300. Again, see
100, yeah.
3 is there, 1379 category, and there are 2 zeros. So it's 0.01 because it is coming in this one. 0.01 into 169 by 3, so it is 38 plus 2 by 3. So 0.38 becomes this fixed part, and this is 0.666, so this is 38.6.
66667.
It will be done. So this is the idea. Now next I come to decimal form to rational form. I'm doing the opposite one now. For terminating decimals, denominator becomes 1 followed by as many zeros as numbers of digits after decimal point. Then we write in minimized form if required, like 0.125. So there are three digits after decimal. Okay. So what we do? We write 125. We leave that decimal point, and we all learn these things. Maybe that's a division. Or because there are 3 digits, so you write 3 zeros after 1, that means 1000. And because when you cancel it, it becomes 1 by 8. 5.48, 548 divided by 100, so it is 137. 137 divided by 25. For pure recurring decimal, put as many 9s as in the denominator as the number of digits recurring. Then minimize. 0.3333 is 3 by 9. If these are not there, this is the only recurring one part. Suppose if you can block it in any way. If you consider suppose by mistake you tell okay, it could not identify that it is recurring decimal of 3333. Suppose you by mistake you do like this, or purposefully you write like this. You can do it. You are at liberty to do this. Although it doesn't mean anything, 0.33 is sufficient, 0.1 dot is sufficient. Still you can do it. The result will be the same. It will be 33 by as many recurring as many in the 9 in the denominator. So we put 99. Again, it will be 1 by 3. Result will be the same. So by mistake, if you do not identify where it is ending and so on, result will always be same. 0.4545. So 45 by 99 is 5 by 11.
Sir, do we have any shortcut in Vedic mathematics for kind like 0.6225? 0.625 will be 625 by 1000, right? 10,000. So in that case, do we have any shortcut like see what happens is most of the time we have a big digit. Like if I have 0.13334, like it's going 133. It's a non-reoccurring, then occurring. So that kind of cases we have 0.13333.
Yeah.
Okay.
5 element. We'll come to that shortcuts. We first learn with the this method of recurring decimal. You will be understanding. Okay. Now again, this one 142857. So this is a number recurring with 142857. So it is recurring like this, and we find it 142857 divided by 99999 is 1 by 7. Okay, so that way. And again, what to do it if it is mixed kind? If it is mixed kind or mixed kind of decimals, in the denominator put as many 9s as the number of recurring digits, followed by as many zeros as number of fixed digits. On the numerator, subtract the fixed part from the total, like this. See? You understand? By giving.
Yes, sir. Like why same question I have asked you, like 0.1667.
This is actually 16.
Yeah. 0.1334, 133 will be again same, right? We'll have 13 minus 1 divided by 90. 0.1333.
133?
So for that also we'll have 13 minus 1 divided by 90.
13 minus 1, exactly. 13 minus 1 divided by 90.
So here we are trying to see that 13 is near to 10, like it's a double digit. So we'll consider 90. If it goes to 1000, then we'll go to 990. If we go to 10,000, then we'll go to 9,000.
No. You don't have to do it. So this is not the earlier consideration need not be there. Here actually very simply, as I told, there is a put as many 9s as the number of recurring digits in the denominator, followed by as many zeros as the number of fixed digits. On the numerator, subtract the fixed part from the total. Means here is 16 minus 1 divided by 90. That is the thing. Okay, that here also you did. Achha, 0.6818181. 81 you have to do this one. As I told you, by mistake, if you do something like something extra, suppose you consider this 68 is the fixed part and 181818 my recurring part, you will get the same result. You can try separately. I will not discuss here. So, like 681 minus, so 681 is the total part because 81 I was repeating, and 6 is my fixed part. So, and then followed by 99 was this two. There are two recurring 181818. Sorry, 8181. So it is 99, and one is fixed 6. So it is one number of 0. So it becomes like this, and finally it is 15 by 22. So 1 5, then 3 to 3, 3 to 3, 3 to 3, 3 to 3. It is coming 3 to 3. So 15323 minus 15, 99990. So it is 15308 990. I will go 3827 divided by 24975.
Sir, for here, like 0.15323, 323, we got 3 digits occurring. So we'll have 3 9. In that case, if we have 4 digits occurring, we'll have 4 9.
4 9s, yes, exactly. So as I told you, as many 9s as the number of recurring digits. As many 9s as many number of recurring digits, and as many followed by as many zeros as the number of fixed. Okay. Now, decimal expression, we have learned how to calculate decimal in terms of in our conventional mathematics. We already learned how to after we got a remainder, how to continue to get decimal points. You remember how to do normally do like this. Suppose I do 34 divided by 7. Okay. So 28, we got 6. Now this 6 actually is less than 7. So this is the depending on the question that okay, we do not want further. This is my quotient and this is my remainder. 4 is quotient and 3 is remainder. But suppose I want to do decimal fraction. What do you do? I put a dot decimal and put a 0 here. And now they can do 8. So 56. Okay. So because of the effect of the 0, you keep on putting. Because of the effect of the decimal, we keep on doing this decimal. We keep on doing continuing our division. So like this, we continue like this. So similarly, same thing can be done. I've shown that same thing can be done in Nikilam method also, where you put a 0 and then again you do -1. It becomes a little complicated to learn, but it's not impossible. So that way with 7 you get like this. Here we get like this, and finally get it will be repeating always. So it will be you will get that it is like answer is like this recurring decimal. Here also in Nikilam method also you'll get it. Like I've shown that it is 22 by 7. I finally got it 3.142857 like this and this. So it is possible that way by always dividing again by doing going to another process that whatever quotient you are getting, you are contributing, you will be adding to that one. That will be one by one. But both these things become very complicated. I will come to that. So therefore, this is recurring decimal has a different kind of formula, different kind of ways. We call basic one-line method, or I named it also because of some reason. I tell you later that is called we can better name it Vedic binomial one-line method. We can also call if somebody suppose don't want to keep track of the origin of that Vedic origin, we can call it binomial one-line method also. This is the decimal point. So first we do this once we have to be learning. It starts with when the denominator ends in 9. Earlier we told 1379, but here we starts with only 9. The fraction where the denominator ends in 9, and these and many others of the second type. This second type means 1379. These as earlier are quite long and cumbersome, both in conventional division method as well as Nikilam method. Conventional method also you know sometimes it will with 1 by 19 if you get so many digits it will be very lengthy. I'll come to that. And in conventional, this Lichtenheim method also is complicated, and conventional method also is only ending in only 7. Suppose we divide by 59, it will be up to 58 digits. So you will be a lot of even 19. Suppose something by 19. Suppose say 7 by 19. It will be 18 digits long. 18 digits, something 18 digits. So a lot of 18 digits. You have to do conventional method also as well as Nikilam. So that's what I wanted to tell you here. Many of the discussed earlier are quite long and cumbersome, both in conventional division method as well as Nikilam method. Now, Vedic one-line method, or as I told, binomial one-line method, arising from the sutra Ekadhikana Purvena, is easy, having more than one ways, and it reveals further properties of the fraction such as cyclic property, nice complement behavior, and so on. It will be completely different kinds of learning we'll get with this binomial or sorry Vedic one-line method. Vedic one-line method is directly applicable for denominators ending in 9. For denominators ending in 1, 3, and 7, we can multiply both numerator and denominator by 9, 3, and 7 respectively, so that the resultant denominator ends in 9. Like what is told here. It is told that suppose I have to do something, say 3 by 7. Okay. How will be calculating 3 by 7 with the knowledge of ending in 9? Somebody speak, mic is on. Acha. So you have to multiply both numerator and denominator by 7. So that becomes how much? You tell me. 3 by 7 becomes how much? 3 by 7 will be how much? When I want the denominator to end in 9.
So 49, 21 by 49.
21 by 49. So suppose I have to evaluate 3 by 7, I do 21 by 49, while 9 is actually 49 is ending in 9. So this procedure will work. Actually, this procedure I am going to learn now. We are going to learn. So, so that is, you understand. So this Ekadikona Purvana and it is applied, and all these different properties called cyclic property, 9's complement, we will all learn there. And anything other than the ending in 9, 1, 3, ending in 1, 3, 7, 1, 3, and 7, you will 9, 3, and 7. You other things actually you mean to say, already discussed, ending in 2, ending in 5, ending in 8, and so on. It will be easily can be broken in terms of two things. One is purely with comprising of two powers of 2. Another is ending into 1, 3, 7, 9. So therefore, we will be focusing to 1, 3, 7, 9 category, and out of that, only 9 we are considering, because others can be converted by multiplying appropriate digit in numerator and denominator. So it becomes 1, 3, 7, 9. Only 9. So it becomes, we start with 19. What I do first, like this. So Vedic one-line method, case is 1 by 19. Instead of dividing 1 by denominator 19, we start dividing 1 by the digit divisor, called digit divisor is created like this. D plus 1 divided by 10, so or 2, but in a special way. In a special way, not the conventional division of division or finding. Yes, conventional division up to finding quotient and remainder, not beyond that, not fraction. This also comes from the sutra Ekadikana Purvena. Like this, Purvena of 9 is 1. So Ekadikana is 1 plus 1 is 2. That is the idea of Ekadikana Purvena is applied here. So Ekadikana Purvena. So I'm sorry, 1 minute. So you got the idea that either we can call it Ekadikana Purvena, or you can, this formula I can use. Now the procedure is like this. Put the decimal point. So I put a 0 point, 0 and put a decimal point. I'm starting the 1, actually 1 I am dividing by 2. When I divide 1 by 2, can you tell me what is the quotient and what is the remainder?
Zero and 1.
0 is my quotient and 1 is my remainder. 1 I put slightly below like this. These are all given here, expression here. So this looks like 10. So when I look like this, my head slightly tilted. So therefore, I purposefully write on the left of that. Or we can say that the remainder we will use as a tens digit for this one. So that becomes 10. Now 10 divided by 2 is how much?
5.
5. Now again, and remainder is 0. So either I can write 0 here. I can write 0 here, no problem. But when instead of writing 0, I can just omit it. No problem. Now 5 divided by, because 0, 5 and 5 is the same. So therefore do not write. I say 5 divided by 2 is how much? Quotient and remainder?
2 and 1.
2 and 1. So please continue. Different persons, you know what to do? I look like this, or I consider it to be 10th digit. This is how much?
1 0.
This is how much? This one? 2 and 1. It becomes?
1 0.
12.
No. 12. It becomes 12.
Okay.
Slightly head tilted. I look at it. 12. 12. So 12 divided by 2. I continue to divide by 2 only. Don't have to say it like this.
Okay. 6 0.
6. 6 0. 0 I do not write. Then after 6?
3.
3. Then how much?
1 1.
1 1. Then how much?
5 1.
5 1. Exactly.
Seven 1.
Side by side, you can write on your copybook also.
8 1. 9 0.
Here, this part I will write it. You told 9 0, isn't it?
Yeah.
Then you write also side by side. All of you, please write on your copybook. And as I told that up below 0, I am writing 9. For this purpose, I will explain later. Then after 9, what is the thing?
4 1.
4 1.
7 0.
7 and 0. 0 did not write.
3 1.
3 1.
6 1. 3 0.
No. 8 0.
It is 16.
16. Oh, sorry.
8 0.
8 0. 4 0.
You are writing not on a paper side by side, no? By pencil you write, so if you commit any mistake, then you can erase it.
2 0.
Back to 1 divided by 2.
1 0.
1 0.
So therefore, again after 1, it will get again 0 and 1, 5 and so on. So I put a dot here and dot above this. So this is my result of the 1 by 19. Actually, basically 1 divided by 2, but actually it is the result of, this is the result of 1 by 19. See, where was 1 by 19? And you remember there's so many 18 steps were supposed to be done. Instead of that, I did in one line. So this is the beauty of the Vedic one-line method. Here, purposefully, I asked you to write or I wrote and or asked you to also to write 9 below 0. Now you see the property. It has 1 by 19. This is actually 1 by 9. Or something, anything by 19 actually will contain. It will be containing 18 digits. 18 digits it will be. Anything say 1 by 19 to 18 by 19, all these things will be 18 digits. The 18 digits I will divide into 9 digits each. Now, writing it below, it will be very clear. If we add up this 2, it will be all 9. See, 0 plus 9 is 9, 5 plus 4 is 9, 2 plus 7 is 9, 6 plus 3 is 9, 3 plus 6, 1 plus 8, 5 plus 4, 7, 8, 1. And the remainder adds up to 1. This is adding up to 9, and this is adding up to, remainder is adding up to 1, and their digits are adding up to 9. This is very clear. The digits themselves are adding up to 9, and the remainders is adding up to 1. This is 1, 19. So what we could have done, evaluating it halfway, we could have directly subtracted from 9, 9's complement. Nikilam navatas, they are not taramatas, Nikilam navatas. Nikilam, all these things are subtracted from 9. Is it not interesting? So I continue. I mean, we did already, so I just revise. Successive quotient Q and remainder are in the form RQ are as follows. From beginning of 1 by 19, remainders are written left in small. So it becomes 0. And did you do it on your copybooks? You just please match whether I did it correctly. 0.052631578947636842. At these 18 digits, we again arrived at 1 from where we started. Thus, the sequence will repeat. Thus, 1 by 19 is basically this one, 0.0152691 and 1. Recurrence length is 18. It is possible to get same result from right to left also by starting with the same numerator and multiplying with 2 and adding the carry written left in small. That is actually if I do like this, for example, like this. Suppose I could have started, instead of starting, say, dividing 0 by 1, the cursor is going. Yeah. We started with 1 by 19, actually, basically 1 by 19. We started 1 divided by 2. So 0 was my quotient and 1 was remainder. Then we continued like this. Instead of that, this 1 by 19, I could have started with 1. 1 into 2 is 2. 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 16. 6 I put here. 1 I put as a carry. 6 into 2 is 13. So 3 I put here. 6 into 2 is 12. Plus 1 is 13. So 3 I put here and 1 is here. 3 into 2 plus 1 is 7. No carry. 7 into 2 is 4. 4 into 2 plus 1 is 9. 9 into 2 is 18. So 8 I put here, 1 I put here. And so 8 into 2 plus 1 is 17. So 7 I put here, 1 is. So that way you can complete the opposite way. Somebody wrote
the word like 1 by 29.
Yeah, I mean, you are thinking a little advanced. So I come to my problem.
Yeah.
So the thing is that so therefore this is also can be possible. In case of full cycle like this, 18 digits, 1/2 of length of these things and 9's complement to the other half. Thus, after evaluating 9 digits, we could have gotten the rest of this rest by subtracting from 9, and please see above. Please note corresponding remainders are also added to 1, dd minus 1. Means actually this is the first digit actually. Okay. So this is 19. So all the digits actually add up to 9 and the remainder add up to 1. Now I am coming to 1 by anything n by 19.
Gautam ji, now the time alarm rings.
Okay. Oh. And now see, just wanted to say that from this one, all the answers are there in one line.
Yeah.
What do you want? Anything else you want? Somebody please tell.
After the Prarthana, as Babu says.
Just one to maintain the continuity. Suppose I want 13 by 19. How much is it? This is 13. I look at that this is 13. So this will start after that. So 13 by 19 is, you can take from your calculator that it is 0.68421. Goes back to 0.52363171578947 and 3 ends in 3. So okay. So after Prarthana you can slightly continue and then you can leave for tomorrow.
Right. Babu garu.
ధన్యవాదములు. Gautam ji, thank you so much.
Namaskar.
I just for the time being, I have removed that sharing. After Prarthana, again we'll resume for question answer session. Okay, now let us request Bhaskar Rao garu to chant Swasti Mantram, please.
Okay. स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पौत्रिणः अधना सधना सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान् मां प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः ॐ पूर्णमदः पूर्णमदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते हरिः ॐ श्री ॐ शान्ति शान्ति शान्तिः स्वस्ति.
ధన్యవాదములండి భాస్కర్ రావు గారు. So I request everybody to chant along with the chanter, and also while chanting you understand what is the meaning of that, each sloka, each word. When you also understand, then you really will be praying. Otherwise you are just reciting. So I request all of you, I have already given the meaning of each sloka in English. So go through that while chanting, you remember that. I request everybody to rise for national anthem, please. Chala Chittibabu garu, please.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उत्कल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद
जय हिंद. ధన్యవాదములండి చల్లా చిట్బాబు గారు. Thank you so much. Now, let us continue. If any questions and answers are there. Any questions, please, Mohan? Mohan?
Yes, sir. The fractions which we dealt previously, I think maybe 3 to 4 slides ago, are they Vedic maths methods, sir, or conventional methods? I mean,
Yeah, Gautam ji.
sir, you are on mute, sir.
Gautam ji, unmute. Just a minute.
Do you hear me? Yes.
Yes, sir. Yes, sir.
So here, these concepts have nothing to do with Vedic mathematics or conventional mathematics. These concepts will be same. This actually, this transformation and this one, this will be all same. These are the basic theories.
Basic. Okay.
These are the basic theories. And see, earlier we did by basic mathematics method, we found out the quotient and remainder. But when we do what is the meaning of the quotient remainder in terms of the division, and what is the expression for quotient and remainder with divide and divisor, which will be always the same thing. This is just algebra. And similarly, this formulae, this thing, like that kind of properties will be the same. It is nothing called basic mathematics in this. It's not a separate. But obviously, it was known always. Otherwise, how earlier people could do it, isn't it? So therefore, earlier this recurring decimal was done like in this method instead of a conventional method by division this way. The recurring decimal is done in that one line method I taught. So
Okay.
concepts are known, obviously. You call it basic also and call it conventional also. They're all the same.
So
Yes.
division method, I am not fully comfortable. I'll practice again by watching this video. If
Sure.
not, can I reach out to you, sir?
Right. Sure. My numbers is given already.
Okay. Yeah.
So you can drop me mails. So
Sure, sir.
did you understand? Could you find it comfortable? All right. That suppose I started with 1 by 2. Suppose you tell me from this sequence we wrote. When I wrote on this thing, I wrote on your copy. You tell me what is the expression for 15 by 19?
15 by 19. Okay. Actually, 1.5. Ekadikana Purvana 15.
No, it is already here. It is in front of you.
Okay, 15. Yeah, it starts from 1718.
7.
Yeah, 7.
15
Yeah.
by 7, 15 by 19 will be 0.7894736842 then is 0, 5, 2, 6, 3, 1, 5.
5
It
again.
ends in
Yeah.
5.
Yeah.
Whereas 5 by 19 will be this one. This is the 0, 5. Only 5. So
Yeah.
it will be 5 by 19 will be 0.263157 and so on, ending in up 0 and then 5. So this is in one line. We get all the answers of this, all the answers for all the fractions, expression of all the fractions from 1 by 19 to 18 by 19. So we had to do 18 calculations to get at this. Instead of 18 into 18, 18 fractions, and there will be 18 steps. You put a 0 and so on, it will be 18 steps. Instead of 18 square operations, you are getting only 18 operations. It is square root kind of thing is happening. Operations. So someone asked for 21. So can you take it as a homework? You please do it for 1 by 29. It is actually you have to start dividing by 3.
Yeah.
Anything else you do? Suppose, let me put each one can do, say you do 7 by 29. Please do. 7 by 29 is equal to, then you do 7, dividing should be by what? 7 by, I put a different notation. 7 you have to divide by how much?
9.
3. Ekadikano Purveno means, Purveno is this one, so Ekadikano is 2, Ekadikano is 3. 7 by 3, then you put like 7 when divided by 3 is how much quotient and remainder. So I do not tell. So please, tomorrow you do it. You keep it handy. So tomorrow we'll discuss one by
Like
9.
1 by 39 will be again, like we need to divide by, like 7 by 39 will be, we need to divide 7 by 4.
Exactly. 7 by 39, you have to divide by 4. Okay.
49 will
You try all these things. 49 is 5 and so on.
Yeah. Okay.
And for 29, we have to calculate up to 14 and then direct 9's complement.
Exactly. Please do it. Yes. Please do it. Here is 18 up to 14, and then it's broken down after this one. Simply, they are also this. Their remainders, quotients. Quotients add up to 9, and their remainders add up to 2 here. See from here. Okay. So okay, for tomorrow I left this. You do
Just
it
a minute, there is
without
one question.
looking at this one, your slides. You do it yourself on your pen and paper. Please tell me what you are asking.
Yeah, Padmavati Garu, you have a question, so you can raise. Padmavati Garu?
I'm Guru Garu.
Yeah, you can raise your point.
నిన్న హోంవర్క్ ఇచ్చారండి గురువు గారు 9887 into 8778.
Right. So you can tell in English so that he cannot understand Telugu.
98
regarding yesterday homework, 9887 into 8778. Please explain one more time in Vedic math.
8. How much it is? 8.
9887 into 8778, sir. This is the 8778. 9887.
Tell me how much?
Guruji.
Nikilam Namatas.
Yes, sir.
Charamang Dasata. Oh, sorry.
It will be 0113.
Oh, sorry, I was correct. Yes.
0113. Yeah, 0113.
01, yes, correct. 0113.
0113.
And here minus
0122.
1.
2.
2.
Okay.
Hope you are understanding, Padmavati Garu. Hope you are following.
చూస్తున్నానండి గురువు గారు నేర్చుకుంటాను ఈ రోజు కొంచెం 2-3 days practice చేసి.
Now I do 9887 minus 1222 becomes how much? 8, 6, and 5, isn't it? Then I have to do this one. So for that, what we do like this, again I do like this. So by any method I can do it. Okay. This will become my 1 into 2 plus this. Okay.
Gautamji, you have added 9887 and 8778, isn't it? So you have got 5668. Then there should be 1.
No, sir. 9887 minus 1222.
Okay, minus
Minus.
9887 minus
1222.
Or 8778 minus 113, all the same.
Okay. Fine. Okay. Thank you.
Cross subtraction is doing.
Here I am doing another method. 1 into 2 plus 3 into 2, which is 8.
8.
1 into 2 plus 3 into 2, 8 plus 2 is 10.
10.
Put 0 here, 1 below. Now the four things. 0 into 2, 3 into 1, 1, 3, plus 2, 3, 7, isn't it?
7.
7 comes here. 1 is above that, 1 below that. So 0 into 2, 1 into 1, 1 into 2. That means
1.
Huh?
Carry will be 1.
3.
3.
It is 3.
Then 1. Then
0 into 2 plus 1. 1. 13086. Now 7086 I put here. And this, because it doesn't fit there, so 13 I put. Oh, no, it is 1, 8. It becomes 8. No, there is a 1 carry was there. Okay. 7, this was below 7. And then 13 I put here. Now my result becomes how much?
8678.
8678.
8086.
8086 should be matched.
Yeah, sir, it matches.
This is the idea?
Yeah, it matches your calculation.
So it is a 2 steps formula. One where in one of them it is the easiest was one to use the Nikhila method, and this the other one we used this Uddhati Jagabham to get this one, because these are dissimilar. One is near 1,000, another is near 100. So we cannot do Nikhila method here. We have to do this one. As I told, by matching this with the 0, we did this one. Uddhati Jagabham.
Thank you, sir.
Any more question?
No.
Okay. If no more questions, then we will close.
See you tomorrow then.
Yeah, see you tomorrow.
Thank you, sir.
Yeah.
Thank you.